Of video, how were they? You didn't do. All right, okay, leave it. So as I said, there were like multiple. Now see, signals, we said that we have defined two types of signals, right? Continuous time and discrete time, isn't it? How do they differ? Continuous time, we said that they are defined at each and every instance of time. Now see, that terminology applies to the time variable, okay, the independent variable, not necessarily as to that a terminal or signal may be differentiated based on the independent variable. It may be differentiated based on the dependent variable also. For example, now based on what you know earlier, can you tell me what kind of signal is this? I'm simply drawing like that and assume that this x-axis is the time. Huh? It's a one-dimensional continuous time signal. Okay, but that is not a complete definition of this. Time is continuous. Is the amplitude also continuous? Yes, amplitude is also it's also continuous. Continuous in the sense, you tell me, any, I mean, there are indefinite number of values in between two intervals. That means I can define 4.01, 4.001, and so on. So there are infinite such instances which are available in between these two lines. Therefore, the amplitude is continuous, the time is also continuous. Such signal is called as analog continuous time signals. Okay, so I'm defining the terminologies. Now the signals, okay, can be classified based on the classification of independent variables. Okay, so the independent variable, is it continuous time or discrete time? It can be classified based on the amplitude or a dependent variable. Dependent variable may be continuous. If it is continuous, it is called as analog. If it is not, it's called a digital. You have already seen digital electronics, right? So how were the signals there? 101010. There were only two levels of amplitudes which were defined in those signals. However, the time was continuous. You were not giving the pulses to that, right? You were giving, of course, pulses were continuous in time, isn't it? So now can you tell me which kind of signal is this? So I'm just defining them at some points. Tell me, what kind of signal is this? Huh? Independent. Okay, so you should not say like that. You tell me, you just classify in between these two. Is it discrete time? First you look at the time. Is it discrete time? Yes, indeed. Is it discrete amplitude? The amplitude is discrete or continuous? It's a continuous. Okay, it can take any value. So it's a analog discrete time signal. All right. So this becomes, now let me tell you, this is continuous time analog signal. So analog, this pen is crazy. Analog plus continuous time. This is what this, this, yes. So it's a analog plus discrete time. Is that okay? Is that okay? Now can you give me the other two combinations? Now it should be clear. Which kind of signal is this? You tell me. Suppose I am defining signal like this. Tell me. First look at the independent parameter. What it is? Is it continuous? Yes, it's indeed continuous. It's a continuous time. All right, it's a continuous time. Look at the amplitudes. Can I take infinite number of amplitude values? No. So it's a digital continuous time signal. All right. What about this? Huh? Yes, it's a discrete digital. All right. Or you should not say only discrete time. See, our subject is all related to the time. I mean, most of the time we'll be dealing with the time parameter. Is that okay? Now, if anyone, now there is, see, there is a lot of confusion between the students between these words, analog and continuous. They feel like they are the same. Continuous time and the analog are the same. That's not true. Analog is related to the amplitude. Discrete time is related to, of course, the time, right? All right. So as I said, the variables or maybe anything A, B, C, this may be multivariable function and so on. All right, having known that, we have also seen that if you have been given such signal and we need to determine the size of the signal. Say for example, now see, as we have said that the signal is a variable, is a function of independent variable, so it may vary. All right, I am taking a signal which is varying something like that. It's varying. Can I define a single quantity to measure size of the signal? Why would like to do that? See, I should be very specific about some signal. Say for example, I'm speaking something and you are speaking something. How would I differentiate between two? Can I have a single value to determine the size of the signal? Say for example, my voice is high enough, but I may speak for a low duration. His voice is even higher, but he may speak for longer duration and so on. That means, see, my amplitude may be high, but signal duration may be short. My duration may be short, but the voice may be less and so on. Then how can we determine a single quantity to a signal? We should take into consideration both the amplitude and the time. That's how we landed up in defining a quantity which is called, what would be the simple metric which would should take into consideration both the amplitude and the time? It's the area. Exactly. Yeah, good. So that's why yesterday we have said that we could define a metric based on area, which is simply defined as this is crazy, x of t dt. So this is simple area, but we found that for signals which are negative, I mean, say for example, take a sinusoid. If I calculate its area, it's 0. So that is not an effective measure. That's why we landed up. Now you could say that, okay, I can take its absolute value or I can take its square. No problem. I may take, so another closest metric would be to take an absolute value of x of t. That would make this signal equivalent as like this. Now we can define this area or a single size of the signal, what we can say a metric. All right, but we would like to prefer not this but square of that. We have seen that yesterday. What was the motivation behind that? It gives an indication of energy of a signal. Now energy is what we already know from our basic courses like voltage and current, we all know, and the power and the energy per unit time is the power that we already know, isn't it? So it's closely related to the energy. How closely is it related? We have considered. Can you tell me how closely is it? Is it exact energy expression? Yes. So that's exactly. So that's why we have considered this as a normalized energy where R or the ohmic resistance is unity. Okay. So we bother less about that. R is 1, but we say that as far our definitions are concerned, our course is concerned, we'll always consider the definitions of energy and power as we defined yesterday minus, you tell me. Yeah, so now minus t2 t mod of x of t whole square dt. Now limit, why limit t tends to infinity? Just because we need to consider the area of the signal, I mean all the way around, I mean as long as it exists, right, for all the duration from minus infinity to infinity. All right, this is the, and for power you just need to divide it by the size the duration of the 1 upon 2t integration, tell me, minus t2 mod of, is that okay? Now I have derived these formulas, right? So you don't need to mug it up. Now, all right, we are happy. We saw that signals, we saw its importance, why why we need to deal with the signals. We have defined some parameters to those signals. Why? Just to have some quantity. Okay, this signal is even better, this signal is not better, this is what we want, this is not we want. So how do we differentiate between that? That's why we have defined some quantities which are energy and power. Okay, Based on that, the signals are classified as energy signals and power signals. All right. For example, consider this example. Let's have now, as we have seen last time, we have defined the signals both in time domain and in the continuous time and discrete time. So we shall see the examples of both. Okay, continuous time and discrete times. So consider the signal x of, let's say, now I am defining discrete time signal. Let's say it is some value. What would be the simplest signal, as Nipun has said yesterday? It would be some constant value. I mean, I will be very lazy to define some signal, so I will say that okay, it's a constant value. Let's say it is 2. That for all the time. So for all n. So for all, I can represent like this. For all n. So how this signal would look like? Can you draw this signal quickly? How this signal would look like? Like this. So all the time instances. Okay, n is the, what is n? You tell me. Yesterday I have defined n. What is that n? So let this be, let's say 0. Okay, 0, 1, 2, 3, and so on. -1, -2, and so on. What is its amplitude? 2. All right. So from minus, so see here, n is an integer. So you should not ask me now. This is a discrete time signal. Okay. The value here in between those two samples is undefined. And say, look at that grid. So there are dots, but between those two dots the value is undefined. Same is true with our images or photos. There can be only values at between specific points. There's no value in between those. That's undefined. We can't define that, right? So because we don't have any value, how can we define that? Now, can you calculate its energy and power? You can do that. Yeah, calculate. So discrete time equivalent I have told yesterday. What is the equivalent of discrete time? You tell me. Simply replace the integration by summation, and the division will be with respect to what? What would be a division factor in the power? 1 upon 2n plus 1, right? Go for it. Calculate its energy and power. This is the signal. Quickly do that. So what is the formula to be applied? If I need to calculate, first calculate the energy. Okay, E equals to, tell me, limit. Bolo. N tends to summation. Bolo. N equals to minus n2 mod of x of n whole square. Should I apply dt there? Should I apply dt there? What is dt here? You might have seen dt, that's in integration, but what does that mean? Yeah, so yesterday I have demonstrated, like if I take small steps and go on, I will cover a distance. That's what the integration means. Is that okay? Yeah. Can you tell me the value here? How much is this? Equals to limit. See, you should be very careful during the calculations. Done? Huh? Huh? 8n. 8n means? Okay, 8n. All right. Okay. 8n. Okay, let's see. So it is what? 4 and summation, right? So summation. No, this is from n equals to minus n to n, and this is what? 4. How much this is? 4. Oh my god. Based on your knowledge of JEE and your first year exam, can you tell me the value of this? Have you came How? Okay, 4 into 2n plus 1, right? But there is also limit, right? After putting L, you tell me. 2n plus 1. See, 4. How you got this? There is a 4 amplitude. You need to add this 4 how many times? Minus n to n times. That means 2n plus 1 times. So 4 into 2n plus 1. Okay. So this is equals to, no, this limit n tends to infinite 4 times 2n plus 1. That's okay, but when you put the limit, answer would be infinite. That answer your question. Okay, yesterday's question, that will this energy, now we'll come back to that point. So energy is infinite. Is energy infinite? Does that make sense? Yes, because see, this amplitude is never ending. From minus infinity to infinity, it is constant. And if I go on making the square of each and every amplitude at each and every instance and go on adding, of course it would end up in infinity. That's true. Let's calculate the power. What about the power? Huh? Yeah, good. So the P turns out to be 4, which is less than infinity, and of course finite value. You got it? How do you calculate 4? Okay, I'll tell that. So to calculate the power, what is the power formula we have written? Tell me, limit, bolo. I'm not able to write it properly here just because my pen is not working properly. N tends to y, n tends to infinity. Bolo. 1 upon, why this 1 upon 2n plus 1 is required? It's an average energy per unit time. No? Energy per unit time would be the power. So energy formula remains the same. What is the energy formula? This is N equals to minus N to N mod of x of n whole square. This is the energy. Energy per unit time would be the power. And it n tends to infinity just because we want that signal. I mean, we should be careful about, if, see, it may happen that I'm speaking something, but at the end there will be some components which would be remaining, so we take care of all those components. Yeah, so what would be this? Limit n tends to infinite 1 upon 2n plus 1. What would be here? 2n plus 1 times, now that gets cancelled, right? So how much it would be? Now you should appreciate why I have put the limit, n tends to infinity here and didn't put infinite directly. Yesterday you might be questioned like, why didn't I put this, n equal to minus infinity to infinity there? Otherwise you could not have evaluated, because you need to take care of those cancellation factors also. You got it what I'm saying? If I would have directly placed n equal to minus infinity to infinity here, and you would have calculated, you would have ended up in getting the answer of infinite. That is invalid, because we wouldn't be able to cancel those 2n plus 1 terms. Is that okay? Is that okay? I'm seeing some blank faces. All right. So this is less than infinite. Therefore, no. See, it's now okay. However, you consider this signal. Now another example. Consider the signal x of n. Okay, I will consider this. Now I will consider continuous time signal. Okay, just to differentiate. This is what. Let it be 1 for t. Okay, I'll write 0 to 1, both included, and equal to 0 otherwise. Calculate. Calculate energy. E. Bolo. Formula bolo. Energy. E. First look at the signal. Is it continuous time or discrete time? It's a continuous. What would be the formula for continuous time? Bolo. Limit. What tends to infinity? T tends to infinity. That's why I've asked the first question. Okay, t tends to infinite. Energy है ना, तो 1/2 वाला फैक्टर नहीं आएगा. Integration बोलो. minus t2 plus t, उसके बाद x of t, don't forget the mod of that का स्क्वायर dt। बोलो क्या आएगा इसका? huh? Yes, we need to separate the integral, right? Just because it's 0 on the left hand side, it doesn't matter, right? It will be 0. So I'll consider only the integration from 0 to t. Is that okay? This would landed up in 0 to t or 0 to 1 to be specific. It would be, yes. So what would be that? Limit t tends to infinite. Integration, you tell me, 0 to, yeah, I mean, okay. See, okay, fine. I'll just timing write that 0 to t mod of, now this is 1, right? 1 square is 1, of course. I'll write that time being, and if that is removed, it will be t, right? Yes, exactly. All right. So how much is the energy now? It is, all right. It is 1. So this will get limit t tends to infinite, and this is defined between only 0 to 1. Okay, so the answer would be 1 here. Is that okay? Is that okay? Calculate the power. Calculate the power. Power. Power 0. Sure. How? Okay. That answers your question. Yesterday, which you have asked, you said that the power would be 0. Indeed, yes, it is. For what? For now, this such signals which are having. Huh? You said something. Okay, I'll come to that point. Okay. Let's make it very clear. Now there is a differentiation. Let's make a table here. See, again I'm saying that it's an average energy. It's not total. I mean, in average energy per unit time would be 0. Instantaneous is different. Average is different. Instantaneous, of course, they would exist. That's why I've defined the power yesterday as V of t into I of t. That is instantaneous. That's not true. Here it's a energy per unit time. And the average energy, because we are considering the integral and divided by that, isn't it? By the duration of that. Yeah. So that is good insight. So what I'm drawing here is, it's very simple. So I'll just, so energy and the power. If the energy, all right. Now, what was the case earlier? In the first case, how much was the energy? It was infinite. How much was the power? Power finite. So finite means, of course, it should be greater than 0 and less than infinite. All right. Such signals are called as energy. This is called as power signals. And whose energy is infinite. Oh, sorry. Finite. And power is 0. It's called as energy signals. Now, there may be a case where both are infinite or both are 0. Those are neither energy signals nor power signals. So, neither nor. An example would be, now can you calculate, now I am giving an example. Consider this signal, all right. The signal is something like this. It begins Okay, I'll just express that mathematically. So x of t equals to t for, it's t greater than or equal to 0 and less than infinite. So it grows on. Okay, I'll write as t greater than or equal to 0. All right, and draw the signal quickly. Simple ramp, slope, straight. It's by slope 1, right? So such kind of signal is called as ramp. Just because, why ramp? Because it looks like ramp, no? Like a step. It doesn't have steps. So all right, so it looks like this. What would the slope? Tell me. 1, of course. So slope is 1. So slope is 1. Can you calculate its energy and power? Huh? Huh? 0, of course. Yes, so that doesn't, it's 0 otherwise. All right, good. So Kirti said, yeah, Ashutosh, energy is infinite. What about power? Great. So such kind of signals are classified as neither energy signals nor power signals. We hardly would deal with this such signals. Okay, most of the practical signals. Okay, now you should, okay, you calculate, then otherwise you won't listen. All right, so again, finite value, that won't happen. That won't happen. Why? You tell me. Homework for you. That's what the that was the question by Karthik yesterday. He answered. You tell me, no, why it won't happen. Energy, you if you get energy as some finite value, because power is having energy and per unit time. Finite energy for infinite duration, of course it will be 0. So it won't happen. So that's why I didn't consider 0 0, please. All right. All right. यहाँ तक समझा? Let's do some more practice. Because last time I got some feedback saying that we should practice some more. All right. Consider this power signal. Okay. Sinusoid. Okay. I told you already it's a power signal. So consider this signal. This is, how do we define this? X of t equals to, is it continuous time or discrete time? You first time. Continuous time. All right. Is it analog or digital? Analog, because at every instance, at every state, or the instance of amplitude, okay, at every point in the amplitude we can define certain values, right? So let, how it is defined, you tell me. A cos omega t, where omega is 2 pi f. Okay, I won't go into the details of this. Omega is 2 pi f, where f is 50 hertz here. All right. A is how much? It depends. We are considering RMS value or peak to peak. So what is 240? So peak to peak, or so go for the same. First calculate the energy. Calculate the energy. Calculate the energy. Quick. Solve these examples quickly. I'm giving another example. See, try to, whenever you are calculating such values, don't directly jump into the equations. First, look at the behavior and draw graphically how the signals would look like. Therein you can get an idea. The thumb rule is, I'll tell you the thumb rule later, but first you solve this. Try to solve this example. X of n quick. Let me see how many of you are able to do it. Let me know, please, if you are not able to understand.
Sir, infinite. Sir, energy infinite.
How did you arrive at infinity? What is okay. We got it down just because sine of t what would be sine of omega or capital T. That's what you have done. Yes. No matter what the argument is, in the trigonometric sign value, it is always a finite. That's why it's very. You take any value. You take any value in the argument, that's going to give you. So it's like sign of any argument will always be in between 0 to 1. So that will of course be finite value. That is tending to infinite just because of that p which is coming into picture. You got it? How many of you are not able to solve? How many of you are facing difficulty? Please tell me. Because in initial stage I can help you, otherwise it will be too late to help you. How many of you are facing difficulty? Raise your hands. Go ahead.
The power is not.
I've taken this power signal, right? This signal I have taken, supply signal. Supply signal is defined as what? It is having some amplitude. It is having some frequency. How much is the frequency? 50 hertz. How much is the RMS amplitude? 240 volts and so on. So you go step by step. Don't skip the steps. Okay, if you skip the steps, oh, then okay, I should go for some more tongue twisters, right? So if you skip the steps, then there will be a problem. Let's go step by step. So energy, first you calculate the energy. How do you calculate energy? Apply the formula. Limit capital T. This is different from small t. Tends to infinite. Bolo. Integration minus to t. बोलो यहाँ पे x of t का स्क्वायर मॉड ना dt. बोलो ये कैसा आएगा? लिमिट. Solve with me. Now how? Yeah. Minus t to t. This is a square cos square omega t. Is that okay? dt. A square is anyway constant. I can take it outside. So equals to a square limit t tends to infinite. Tell me the value of cos square. This how much? How can I write that? I should simplify that, right? 1 plus cos 2 omega t. Is that okay? Yeah, 2 I will write it here. Anyway, it's a constant. Tell me. A square by 2 limit t tends to infinite. You tell me this, how much this is? 2t. How much this is? Well, it's a minus. I will take it common, right? Integration of cos. Okay, minus won't come, right? So okay, so it will be how much? You tell me, sine 2 omega capital D, right? Minus, no, 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 no. This, yeah, it will be 2, right? Divide by, yeah, okay, 2 omega will be there. Yes, yes, yes. But as that is also constant, I can take it outside. What with the value of t tends to infinite? Now this, see, this will be finite, of course. If now, see, I'm yet to put the limits. Limit is from minus, sorry, I put the limits, but no, t is, now I should replace t by infinite. If I replace t by infinite, this sine omega t term will of course be finite. No matter what the argument is, sine of any argument is some values which is between 0 to 1. All right. Oh, sorry, minus should also be considered, right? I mean, yeah, I mean, because it's a minus, but cos, for cos it's always, no, it depends. I mean, it's the minus, the argument is minus or plus. So there'll be, I mean, mod I should consider. Mod of this will always be from 0. Is that okay? You take any value, but this t will make this complete thing to infinite. If energy is infinite, we should go for check for power. Okay, go for power check. All of you got this a square? No, there should be some more thing. No, it should be 2 there, right? Because 1 plus cos 2 2 cos 2 omega t by 2 should also be there, no? No, no, it a square by 2 it should come there. Let's solve it, no? Yes, let's solve it. कितना है? Nipun, solve it again. Okay, so I think power also, so power turns out to be, you solve it again, Nipun. Check, check it again. So I think it's a square by 2. What is missing? You check. Which is less than infinite. Yeah. डिवाइड बाय क्या है यहाँ पे बोलो, पावर डिवाइड बाय 2t, he has considered 2t plus 1, okay, again that will be still but he has done the yeah, so for sin omega t by omega t कितना लिखा, t tends to infinity, that's what I was saying. Yeah, what, yeah, energy is how much, energy is infinite, power is a square by 2. So what signal this is, you tell me first. Eh? Okay, I know, no, this one you tell me, this signal is what, power signal, right? This power. What about this, you tell me, energy, energy finite, right? 4 by, which is less than infinite. What is power? 0. What signal this is? Energy signal. How many of you didn't get this? किन लोगों को नहीं आया है? 4/3 किन लोगों का नहीं आया है? I'll come and check your copies. 4/3 किसका नहीं आया है? हाँ? सॉल्व नहीं किया, ओके, अभी तक सॉल्व करो, ओके, घर पे जाके सॉल्व करो. Everyone got this? Okay, now look at this. Now how this is energy and how this is power signal, you check here, see here. What was the first example of ours? पहला एग्जाम्पल कौन सा था, सबसे पहला? So there L'Hospital would apply, na? This sign, this infinite by infinite form would come, and then L'Hospital you would apply, right? This was the signal. Now see, I'm analyzing the signals which we have seen so far. Okay, what was this signal? X of equals to this constant. Let's say it's C. Any constant. I'm okay. 2 for time being. What about another signal? Next signal कौन सा था बोलो? कौन सा था example? हाँ, ओके. सो ये ऐसा था ना, छोटा सा. Is it okay? X of t equals to 1 for, all right, ये ठीक है. थर्ड सिग्नल बोलो. जीरो अदरवाइज. चौथा सिग्नल बोलो. है कौन सा, अच्छा एक कॉस, ओके, कॉस ना, कॉस था साइन था, कॉस, ओके. सो इट विल बी this x of t equals to a is the amplitude, right? Cos omega, what was x of t here? T for, और फिफ्थ सिग्नल क्या आंसर था, उसको ड्रॉ करके बताओ. किया, वेरी गुड. व्हाट इज द वैल्यू एट 0? लाइक दिस, पॉजिटिव ना? हाँ, मारूंगा आपको. n है या t है? Okay, if you, even if you calculate for continuous time, still it will be a which signal? Energy or power, yeah. Okay, but what is the topic going on? Now you should not ask me to explicitly say everything in the examination. Okay, if you do that, I will give negative marks to you. हाँ. Now look at the behavior of these signals. ये signal कैसा है ये? It goes on, right? It doesn't stop anywhere. That's why energy is infinite and power is finite. Such kind of signals, no, usually the signals which last long, like the power supply signal, again this lasts long, never stops. Okay, such signals are power. Most of the signals which we shall deal with, like my speech signal, I'm saying something, it gets stopped after some duration. It is defined between specific instance of time, or my voice would die out after some time, like this. So the signal which would die out after some time, it is having some finite, significant values in between some specific interval. Such signals would tend to land up in energy signals. So this is energy. You got it? What I'm saying? And most of the time, if you are in doubt, you go for the formulas. This also died out. The signals which doesn't have any bound, it goes on, but it doesn't have any bound on the amplitude also, like this. Those lie neither in, this signals lie are neither energy signals nor power signals. Any other example? Exponential, it goes on, calculate. So this is neither energy nor power signals. Homework for you, you go for this x of and अच्छा दिखने रहा क्या J3n अब दिख रहा है पीछे में दिख रहा है क्या आपको नेहा एबल टू सी आपको अकेला दिख रहा है आपको क्लियर दिखता तो है पर क्लियर दिख रहा है ऑलराइट फाइन सो लेट्स हाँ yeah and okay for all n all right okay so are you aware of okay j is an imaginary number वो आप देखो वही तो कैच पॉइंट है दैट इज द कैचिंग पॉइंट try to solve it now no problem are you getting the things Sahil are you getting sure how much time we have 5 minutes okay I'll discuss some other stuff those who were absent yesterday this will be our official website again I'm telling that any discussion any announcement will be communicated through this website it's your responsibility to check it regularly all the resources shall be provided at this link okay this one eh? What? Okay, okay, I'll tell you. She got the answer for that. See, in go to ECL 201. If you okay for the books you are saying, go to the resources. In 201, if you click on the books, there are two nice books which are available. One is by Alan Oppenheim, Signals and Systems. This is a classical book, and you can think it of a Bible of signals and systems. He's from MIT, and he has his lectures, video lectures are also available on YouTube. Okay, I'll share the link for that. Even if you can search. And another file is by another book is Signals and Systems by Hushu, something like that. HSU. Okay, you can spell anything. So Chom's outline is famous for numericals. I mean, it would have a lot of problems solved. Okay, inside. So I would recommend you to just solve its problem. I mean, first look at the problems. Don't solve the solution. Don't look at the solutions. You solve by yourself. Then look at the solutions. Okay. So this is one of the best book for practice. Okay. So let me write it down. So recommendation books. So books. I'll deactivate the link after some time. Okay. So first book is Signals and Systems by Oppenheim. Schaffer and Hamid. So it's by Pearson. I've made sure that these books are available in large quantity in the library. You people are around 2024. 20 books are available in the library. At least I've asked that. So there won't be any problem while issuing this book. This is one of the very classical book, and I would recommend this book. Most of our content will be, will be in sync with this book. Okay, and it's okay. Signals and Systems. Earlier it was available with PHI, Printers Hall India. Now it got transferred to Pearson. Pearson has taken all the good books from PHI. Okay, so this is the book, classical book, excellent book. If you want to master this subject, this book is the ultimate solution. Okay, fine. Next, for practice. Okay, practice I will think later. First let me tell you the notebooks. Then it's Signals and Systems by Linear Systems and Signals by BP Lathi, Bhagwan Das Lathi. Excellent book. It's by Oxford University Press. I'm yet to upload that. If I find it, I will upload that on the same link. Third, there are a lot of other books also. Okay, first I won't list down many books. Okay, as soon as I find more and more books, I will upload that on the same link. Okay, just bookmark the link. I will deactivate it from the website. You may find somewhat difficult while going through these books. What students tend to do is they'll pick up some local books. That's fine. Okay, at the beginning you can pick up those books, but some subtle points are missing in those books. So just avoid those books. If you are really feeling difficult, go for the local books. If you want me to tell some local books, I will tell you, because I was also sometime at your place and I also used to refer local books, but later on you should refer this standard books. Okay. Next, video lectures. First, lectures by Signals and Systems lectures by Professor Vikram M. Gadre. Vikram Gadre. He is my guru. He was my PhD guide. The lectures are available on edX. How many of you are aware of edX? How many of you are aware of Coursera? So Coursera is Stanford initiative. edX is MIT initiative. These lectures are available in two parts on edX by Vikram Gadre. He is professor at IIT Bombay, Electrical Engineering Department. Second, video lectures by, excellent video lectures by Dattu Roy, Professor Dattu Roy. IIT Delhi, excellent lectures, superb. Both of them. Each of these professors are having their own style of understanding the things. Now this is available on YouTube. I'll share the links on the resources. I'll make those links available. Just give me some time because I'm not getting any time because of those admissions and all. So now I'm having reason, but later on I'm in invalid.exe. What, MATLAB? Okay, I'll come to that. That's why I was asking for hard disk. I'll come to that. Third, video lecture of Signals and Systems by Alan Oppenheim. वेरी ओल्ड लेक्चर्स. उस जमाने में ये भी नहीं था. उस जमाने में उन्होंने प्रोजेक्टर यूज करके लेक्चर्स लिए हैं. फ्रॉम MIT, अवेलेबल ऑन MIT OCW, ओपन कोर्सवेयर और YouTube. Don't refer any other lectures. These are standard lectures. Refer those lectures if you are available. Otherwise, my teaching will be, if you don't have time to learn all these things, if you want to save times, okay, you can learn many things by referring all these things. If you want to save time, be regular in the class. That's it. Attendance is not at all compulsory, but for the sake of academic accomplishments, okay, and all these things, I may take attendance sometime. I may mark attendance multiple times on that day. If you are absent, you will be marked absent. Okay, when I find less students, I will make the attendance absent. Okay, and if I find less, the student attendance to be less than 75%, then whatever the official procedure will be, that will be followed. Right? Fine. Books, video lectures, what else? Yeah, softwares. Although this course doesn't have any lab, I would strongly recommend to go for the simulations of whatever has been taught in the class. I'll just guide you on, at each and every step. This will help you understand the things better, get more insight into the concepts of signals and systems, and it will also prepare you for the workshop which we are going to, I want some volunteers, so I'm also preparing volunteers indirectly. So this will also make you prepare for that workshop. So I will pick some volunteers from this class so that you will be guiding them accordingly in the workshop, right? So software, MATLAB, we have 50 licenses of MATLAB. So you can sit in the computer lab, okay, on Linux, and the MATLAB is available. Or my style would be, I can give you that crack software which I have already given it to, and if you want me to share with you, just give me hard disk. Avoid that. So I think, yeah, courses. So MATLAB you can, if you don't have MATLAB, go for Scilab. It is excellent open source initiative too. Scilab or Octave. Forget.